This is a chat server written in Rust, about 40 lines, 3 clients talking to each other in real time. Today, we're going to build this from scratch. We'll start with a single client echo server, the simplest thing that works, then we'll watch it break in a very specific way. The fix is going to introduce async Rust, and we're going to make a broadcast, which is where most engineers reach for Arc Mutex, and we'll see why that is the wrong instinct. Let's start with the echo server. I'm gonna run the project to make sure we're good to go. First, we are going to need a listener. This will be a TCP listener. We will bind it to 127.0.0.1. I'm gonna be picking the port 8081. Let's see what bind returns. I believe it's a result. Yep, so we're going to also be making main return a standard IO result. Empty braces in here. Let's make the function also return that. Let's propagate the result from bind to print. That server is listening on, and I'd like to see the address and the port that we are listening on. Listener.local addr. And it doesn't implement display, so we gotta do it like that. This is a macro. So now that we have the server listening on the loopback interface, what we want to be doing is start accepting client connections. And to do that, we need listener.incoming. Listener.incoming returns an iterator that yields result TCP stream. So each call to next, which happens within that iterator, blocks until a client connects, then keeps yielding the new stream. So for stream in listener.incoming, I believe stream is also a result. Yep. So we're going to do if let OK stream from stream. If the client connected successfully, we want to, let's get the client address, stream.peer address. Peer address returns also a result. Let's propagate that up. Now address is the proper type. Let's print that out. Client connected, and here we'll put address. And now, since we have the client connected, let's start reading from that stream. So stream.read. Read requires a buffer. So we need a buffer of 1020 bytes. Let buffer equal to, it's going to be all zeros, of 1024. That's our max read size per call. Read writes incoming bytes into the buffer and returns how many bytes it wrote into the buffer. So let n equal to stream.read. Buffer needs to be mutable so that the read function can write to it, and this will be mutable reference to the buffer. Stream also needs to be mutable. Read should return a result. So let's unwrap that here. TCP doesn't preserve message boundaries. So what read gives you might be a partial message or multiple messages glued together. For an echo server, we don't really need to bother with it, but for real protocols, we need to carefully handle that. Now we have the buffer. Let's start decoding the message. So message is going to be string UTF-8 lossy. Here we can pass in the buffer, and we only want to pass in a slice of the buffer, which is from index 0 till n, like that. And we need to make sure to close that line. Now let's print the message. I also want to know which client sent this message. So we'll do ADDR here. Since we have the message, we print it out to the screen. And this is an echo server. We want to send the message back to the stream. So stream.write all. And we'll pass in the buffer And we also only want to pass in a slice of the buffer, which is from index 0 till n. And this will be a reference. And write all also returns a result. Let's propagate it up. And after this, the client will disconnect. So we want to let ourselves know that we have disconnected from this address. Move the print line up. Let's run this. Server is listening. Let's create another terminal here and see localhost 8081 client connected. Let's send a message. Hello. It sends the message and now we're immediately disconnected. So right now the server reads one message and disconnects and then goes back to accept, waiting for the next client. We need to keep reading until the client disconnects. So to do that, we will create a loop here and we will keep reading and writing back into the stream until the client disconnects. The way how we know the client disconnects, this stream read will return an OK0. OK0 means EOF. The peer has closed their side cleanly, not no data right now, done. So if n is 0, we want to break. Now let's run this server again. Hello, we got a hello back. We got another hi back. So let's see what happens when we add another client. So we're going to add NC localhost 8081. We are connecting, but our server does not say anything about this client. Let's see what happens when this client disconnects. There we go. It says the new client connected, the old client disconnected here, and we are getting the hi back. Let's trace through the control flow. We are accepting a connection. Then we enter the read loop. We are stuck in this read loop until the first client disconnects. The outer loop, the one that calls incoming again, doesn't get to run because we are still inside the inner loop. The OS has client 2's connection ready, but it's just waiting for us to call accept, which is in here. But we never do. We're trapped inside this read loop. Accept is sitting there, ready to receive new client. It just never gets called. This is why people care about concurrency. One thread, one client, no exceptions. The fix is to handle each connection independently, so reading from one doesn't block another. You could spawn an OS thread per connection, that works. It's also wasteful at scale. Threads are expensive, kernel scheduled, megabytes of stack each. The modern answer is async. Lightweight task cooperatively scheduled on a small thread pool. Let me show you. We are adding Tokio. Add Tokio features full. Then we're going to be changing the import to Tokio IO. This is going to be read, async read, and async write extension. Net TCP listener, that looks correct. We are also going to add async here. That'll turn main into a future. Tokio main. This will set up the runtime. We need a runtime to run async main, which is now a future. Futures need a runtime to drive them. Now listener tcp.bind, this will be a future as well, so we need to await it. Next, we need to listener.incoming will not work, so we need to remove this. We will put this part into a loop, and then here we're gonna do listener.accept, which is also a future, so we're gonna await it. Let socket and address equal to listener.accept. We no longer have stream. We'll remove that. We'll also remove this. We'll fix the tabbing. Code never reaches OK, so we'll delete the OK. We're not gonna need this line, so we're removing it. This looks okay. This is gonna be socket read, which will be a future as well. Then this will be socket.write, which will also be a future. Socket needs to be mutable as well. Now we should be able to run this. Okay, server is listening on our loopback address. Let's add another terminal here. NC localhost 8081, client connected, hello. This is working. Let's add another client. NC localhost 8081. We are still not getting it. And that is because we set up our runtime, but we still only have one task in the runtime, which is just main. We changed our types, but we have the same problem. Async itself doesn't solve concurrency. We have one task, main, and it's stuck in the read loop, just like before. Async is the tool. Spawning is what gives us concurrency. Now I'm gonna add Tokio spawn right here. Tokio spawn. This will be an async. Grab all of this, add it in here. This is an async future. We don't have any results that we are returning, so I'm gonna handle these errors like this for now. Unable to read from the socket, and then add the address here. We need to do the same thing for the write. Write to the socket. Unable to write to the socket. Add the address here so we know who was struggling to write to the socket. Need to close this. Spawn tasks need to be self-contained, so we need to move the buffer down here. In here, since every task is gonna need its own buffer, this async task might outlive the main, so we're gonna need to move the socket and address that we are passing in here. So both of these variables will be moved into this task, and now this task is the owner of those variables. Now let's try running this. Server's listening. I'm gonna connect this. Hello, I am client 2. Hello, I am client 1. Both the clients can talk simultaneously. Tokio spawn takes a future and turns it into a task. The runtime now has two things to do: the main accept loop and this connection handler. When one yields, the other one gets to run. A future is the type that implements future, the trait. A task is a future that has been handed to the runtime. Tokio spawn is the bridge. Coming back to the code, it is looking a little congested over here. I want to refactor this section out. I want to call this async fn handle client. Paste all of this in here. We are going to be getting socket and address from here, so we're going to add them as parameters. So we've got socket, which is actually a TCP stream from Tokio. Then the next thing that we have is the address, which is a socket address from standard net. And then this doesn't need to be mutable, but this does need to be mutable. Let's take the handle client throw it in here, and we will pass in socket. That should work. Let's do a quick test. Cargo run localhost 8081. Hello. Nice. Yeah, it's working. Now what we got is a very clean echo server. This doesn't do much. What we actually want is a chat server. So all the clients should be able to chat with each other. And in order to do that, we need to be writing. So client 1 should be writing to the socket of client, all the other clients, client 2, 3, 4, and 5. And we can do this with what's called a channel. A channel would give us a way to handle the fanning out of all the messages. So let's declare that. It'll give us a sender and a receiver, which we will pull off the sender later. So it's gonna be broadcast from Tokyo sync broadcast. Channel, it's gonna be size of 16, and we're gonna put the type in here, which is gonna be a tuple of socket ADDR, and then it's gonna be string, which is the message. This, we will need to pass it through. That is gonna be TX. It's gonna be of type sender. This is from Tokyo sync broadcast. It's gonna be a tuple of socket ADDR and string. We are also gonna have a receiver. That is all gonna be receiver of type broadcast, a tuple here, socket, and string. So we're gonna be doing a couple of things in this loop. The first thing's gonna be we are reading from the socket. The next one's gonna be we are gonna be reading from the receiver, which is the other client sending messages to this client. So we cannot be doing this in a loop, which means we'll be reading from the socket from our current client. Meanwhile, if someone else, which is another client, sends a message over, we'll still be waiting here. We can't be waiting here. In order to solve that, we are going to be using what's called a Tokio select macro. And this macro will let us wait on multiple futures. So the first arm of this is going to be socket.read, pass in the buffer. We will do something when this arm matches. The other one's gonna be rx.receive. I forgot the arrowhead here. And let's remove this. This needs to be mutable. There we go. So after we read, we need to destructure the contents in result. So let's match result. The cases that result's gonna have is OK0, which is the case where we return OK. The next one's gonna be OK with a number, any number. This is the case where we return n, so we can have the number of bytes inside n. The other case is if we get an error, we just want to print that to the screen and close safely. This is going to be a read error from pass in the address and the error as well. Then we are going to return OK. Close this. Let's make this function signature also return a standard IO result. This is a macro. Now that we have the message, let's get it out. This will be string from UTF-8 lossy, pass in a slice of the buffer and dot into owned. Now we need to pass in the sender and receiver here. Sender is gonna be TX, receiver is gonna be TX dot subscribe. We need to clone it, so every single client will get a clone of this and then a subscription for this. Then over here we've got the message. We will print the message and then message. The message, what I want to do is trim off the new lines, and then we want to send this message to the other clients through the broadcast channel. So it's going to be tx.send, going to be our address and the message. That is the first arm is done. Now we need to do the second arm. Here, result is either going to be successful, so it's going to be okay, we're going to get a from, which is the other client's connection info, and then message. And we only want to handle this if from is not us. And then the other option is going to be if it is us, we just want to ignore. And so if it is not us, let's send this message to our client. Put from here and then the message. Then we will socket.write all line as bytes dot await. I am not matching here. Match result. This needs to be like that. This needs to, this is returning a result. So if socket is error, I believe it's like this, we want to return okay. We're not doing anything. The other one is error. If it's a broadcast error, receive error, lagged, we want to let ourselves know what happened. We will say client, our client has lagged, and we've missed this many messages. And the other error we need to handle is broadcast error, also a receive error, closed. That should be it. Tokyo select's not happy. We've got this, and then we have this match arm closes here, this closes here, this closes here. Oh, there. Now it looks good. Let's see if this works now. Oops. Client 1's connected. That's client 1. Client 2 is connected. They are able to chat with each other. And we can see the history of messages right here. Some things I do want to go over. First is select. Select is how a task can wait on multiple futures at once. Polls the arm concurrently. Whichever one resolves, it'll run its branch and it'll throw away the other futures from the runtime. The first arm here is reading from the socket. And when we have a message from the socket, it'll drop the receive arm, and both of it can happen anytime. So it drops whatever future is here, but since we are in an infinite loop, it'll re-register both of them almost immediately. And then the errors that happens when a receiver falls behind by more than the buffer size, we log it and then we continue. We don't crash the task because one client was slow. Closed means the channel is dead, nothing more to receive, so we exit cleanly. The two main things that we covered here is async by itself does not solve concurrency. Spawning does. And channels exist because they solve coordination without coordination. I'll throw the code up on unsafehours.com. I do have a couple of guides there if you're interested in those too. I'll leave the link in the description or somewhere on the video here, or maybe in the pinned comments. See you next week.